Hello, everybody. It is my pleasure to be with you again in the subject of general chemistry. And if we talk about chemistry, I would say chemistry is our life. Not because I am teacher of chemistry, nor because you are students study chemistry, but this is a fact. Look to our clothes. It is chemistry. What we are eating or what we are drinking is chemistry. People diving is chemistry. People go to space is chemistry. Building houses, furniture is chemistry. So this is a chemistry. It is everything. That's why we call it is central science also, because can be connected with biology, with physics, with geology, etc. And it deals with materials which is changing, right? So therefore, chemistry helps us to understand the world, how color changes when plantation grown, the plant is grown. It is chemistry. Metabolomic studies can explain that. It helps us also to be more safe. Why? Because if it comes to since natural chemistry or natural product is everything created by Allah, by our God. But synthetic chemistry, it is created and by ourselves. So that's why chemicals, when it combined together, we have to consider safety. Also chemistry, it is good for us for learning how to be objectives and how we solve problems like climate changes, environmental pollution. This also is a chemistry. How to use chemicals for cleaning our clothes, for example. That's why even our food, our transportation, it depends also on chemistry. That's why we call it chemistry is fun. Science is fun and enjoyable, especially if we really understand the chemistry, not memorizing it. It also helps us to understand many other objectives. Therefore, chemistry could be divided into several subjects like analytical chemistry, which means qualitative and quantitative. Qualitative, what is the compounds of? Quantitative, it means how much. Physical chemistry, it is about changing chemical changes. While organic chemistry, it means compounds containing carbon. Inorganic chemistry, compound doesn't contain carbon. Biochemistry, if I mix chemistry and biology, what is the effect of these substances in biology? Therefore, matter is defined as anything occupied space, and the chemistry studies such matter and how it changed, what's the mixture, etc. And the mass is the amount of matter, right? Let us talk about solid, liquid, gas. Look to the picture here. Solid, liquid, gas. Look, what is the difference between both? Regarding rigidity, fixed volume and fixed shape. You will see this is more in the three factors. These are less. These are much less, right? So look to the picture and then try to see the particles here are closely packed, right? Here is not fixed. Here are not even more fixed like gas. That's why even sometimes a gas, we don't feel about it. However, try to not breathe for a while, then you will feel that you will be died. Why? Because you don't feel about needed of oxygen. So oxygen, for example, is a substance, right? Water, copper, sugar, what we are using in our food, this substance. Then we go to mixture. And the mixture could be homogeneous or heterogeneous. Look to this, for example, this O2. Is it homogeneous or heterogeneous? Homogeneous, it is. If you take sugar and dissolve it in water, it will be soluble very quickly, right? Or salt, and it is uniform, homogeneous. What about this? Heterogeneous. Why? Because you can see two colors, then it is heterogeneous. Here, two colors, heterogeneous, like soup, like here is sand with iron, then it is heterogeneous. If we come to study the change, like solute and solvent, remember, sugar and water, right? If you take sugar and water, I can make it very quickly to you here. If you take some sugar here, and then you take like this one, you take sugar, right? To see solute, and this is solute, right? Sugar, right? And this is solute, solvent, so water. So if you take the water, water is solvent, right? And this solute, low quantity, high quantity. If you add here, it will start to dissolve this, right? Then it will be homogeneous. Look here, you start to dissolve it. Look, huh? Homogeneous, right? So this is what you can see in our daily life about chemistry. Look again to this photo here. What is the difference here of such elements? Here is liquid, here is powder, here is wire. So this means that the status of the element could be of different types. However, it is the same type of atom. So this is mercury, liquid, while this sulfur, solid. This is copper, is a wire, right? Look to this and try also to understand again. Here is what is the difference between here and here, right? If you look here, same atom. So this atom, right? This means that it is a molecule, and it can be two or more atoms, like hydrogen, two atoms of the same element. So it must be two atoms of the same type. This means it is molecule. Oxygen, nitrogen, etc. But while compound, not only one atom, but it must be at least two different atoms like this. So it means that all compounds are molecules, but not the opposite way. Not all molecules are compounds. Like this, for example, cannot be compound, right? Very good. So, therefore, this combination of atom represented molecule, as we have said, which is characteristic for each compound. Let us take a molecule or ions are composed of atoms in fixed and definite properties. What about compounds? Of course, it will be different than the properties of elements, as we have seen in the other one. Another case, which is really very good. You know sodium chloride? This is a salt you use at home. If you dissolve sodium chloride, like the experiment I showed you, it will be soluble in water. If you look to each element, sodium is metal, chlorine is gas. Can you imagine metal and gas? But when it's combined together, it gave colorless plates. That's why the difference between element and compound is that element is a substance made of the same type, as we have said, while compound is made of different indefinite properties. So element is like iron, copper, etc. Compound is like what we have seen, sugar, sodium chloride, salt, etc. If we look here about sodium chloride, here is the sodium and here is the chlorine. And as we have said, this is solid while chlorine is gas. But when it combined together, then it will give you sodium chloride as a molecule of completely different, which is pellets, right? Therefore, we can here make a diagram to show classification of matter. So matter can be substance, mixture, right? And this has physical properties. Mixture could be homogeneous. It means that, as I showed you in experiment, you will see it one color. Heterogeneous, it will be two colors. If you come to substance, it can be element, it means same type, or it can be compound, which is two different, you see, two different. Element is the same. So, therefore, we go to the study of the change. What about the chemical change, physical and chemical properties of matters? Let us take, for example, substance can be identified by their properties with their composition, color, melting point, etc. Do you know what means melting point? Melting point, it is the point where substance is changed from solid to liquid. Like, for example, ice. Ice is water. When it is ice and you increase the temperature, it will convert to water, right? Like in Europe, it is ice. When the temperature increased, then it started to be melted. It means this is the point where it changed. Of course, another solid compound is when you put it in the melting point apparatus and change it from solid to liquid. What about hydrogen gas? When it burns in oxygen, right? It forms water. So can you imagine hydrogen and oxygen? When it combine, it gives water. And this is the chemical property of hydrogen, because to observe this property, a chemical change is done. Like the study of a change. For example, chemists use the measurements to compare the properties of different substances and to assess a change resulting from the experiments. So, if we take the units, what is the units we use? Of course, it is international units, which we use like length, meter, mass, kilogram, time, second, electrical current, ampere, temperature, Kelvin, amount of substances is mole, etc. So this is international units we use. So one use it in any part of the world, it's the same. Then you go to the prefixes uses in SI units like tera or giga, mega, kilo, etc. So all here are example about prefix, symbol, meaning, and example. What about the study of a change? Mass is the amount of matter. Weight is the force gravity of an object. Of course, when we talk about gravity, like apple, if the apple falls from the tree down, it is by Earth's gravity. What about the mass of apple in this case? Is it depends on the location or the weight? Of course, the weight is the same, right? So in this case, doesn't depend on the location, but depends on the weight. So chemists are interested in mass, which can be determined by balance and the process called weighting. So the SI unit of mass is kilogram, as we have said, which is equal 1,000 gram or 1 multiplied by 10^3 gram. What about volume? It means length multiplied by width multiplied by height, like M multiplied by M multiplied by M. So for example, the SI unit of length is the meter, and that of volume is cubic meter, and the cubic centimeter, centimeter 3, and the cubic decimeter is also the same. So 1 liter is equal 1,000 milli, right? which is equal 1,000 centimeter, like this measuring cylinder here. So 1 liter you can measure here by this way. What about density? Density is equal mass divided by volume. So D equal M divided by volume. And again, 1 gram per centimeter is equal 1 gram over milliliter is equal 1,000 kilogram per M3. So let us take example, a gold metal of mass. So you have the mass of 200 and the volume 17.6. What about the density? So density equal 200 divided by 17.6. Again, the same here. If you have here, at room temperature, the liquid is 13.6. So if you take M, it will be D multiplied by V. D multiplied by V, then you can get T. Practical exercise also about piece of platinum metal with a density of 21. So you have here the density and you have here the volume. Then you can get M as well in the same way. And here is the substances of the density of some substances at 25 degrees, like air, ethanol, water, mercury, etc. Now you can see the units. What about heat and the temperature? Heat, of course, heat means that the temperature, and the temperature, it is a measure intensity of heat in a body. Like, for example, you are sick, you put a thermometer in your mouth, then you can measure the temperature. And the 3 common temperature scales is here. Fahrenheit, right? Fahrenheit, 1 factor, Celsius, and Kelvin. What is the difference between 3? And what we are usually used mostly? We usually mostly use Celsius. So Celsius, we use it more than Fahrenheit, more than Kelvin. Why? Because the temperature here of the freezing point is 0, while the boiling point is 100, as you know. So at 100, if you heat the water at 100, after some time, all the water will be evaporated, right? Because this is a boiling point of water. And if you forgot the container and it is open for heating after 100, after some time, all water will be evaporated and even the container will be destroyed, right? But what is different between with Fahrenheit and Kelvin? The Fahrenheit difference is 212 regarding boiling point and the 32 regarding freezing point, while Kelvin is different by 373, even more, and the 273 regarding 0. So this is the difference between Celsius and Fahrenheit and Kelvin, right? Then you will have here, it will be explained to you in different ways. Here, you can see the difference between 273, the freezing point, and 373, 100 degree different, right? Here, in this case, is between 32 and 212 is 180 degree is the difference. So now you can see the difference of freezing point and the difference of boiling point in all cases. What about heat and the temperature? Like melting point of water, boiling point of water, right? For example, in Fahrenheit, we said 332, while boiling point is here 32, freezing point. Here's a degree, 212. While the other one of Celsius is 0 and 100. The third one is 273 and 373. So all of them. What about the relationship of three temperature scales? I think in the three, we can take it like that. 180 divided by 100 equal 18 divided by 10, 9 by 5, right? Then it is 1.8. So this is the difference. If we would like to get it, then 1.8 multiplied by degree plus 32, as we have said. What about if we get C? It will be F minus 32 divided by 1.8. So what about Kelvin and centigrade relationship? Usually we use centigrade degree, right? So Kelvin equal centigrade plus 273, or C equal K minus 273. Think you can convert now 211 F to degree Celsius, right? So there, as we said in the equation, as we have seen in the equation, degrees degree is equal F minus 32, right? So then, sorry, so C equal F minus 32 divided by 1/8. What about express of 548 K in Celsius degree? It will be K minus 273. So you can solve the problems like this way. Also, you can practice here about a certain solder has a melting point of 245 degree. What is the melting point of degree Fahrenheit? Then you can use this equation to get it. Here is the helium and has the lowest boiling point at this degree. You can use the second equation. And for C, for mercury, you can use the third equation. So please practice together in a group with such examples. I hope I have explained it to you in easy way, and please practice on the law. And I hope you have enjoyed with such a chemistry, and see you next time. Please put your constructive criticism. What is good in the lecture and what we need to improve. يا رب يكون علما ينتفع به. Thank you very much, and I hope it will be benefit for humanity of all of our science. And of course, when you share it with others, you will get also hasanat. Thank you. See you again.